Welcome to a section that may not be the most exciting to many of you on the surface. Existence and uniqueness of solutions of differential equations. So we're going to start with kind of the elephant in the room for some of you, is that why do we even care? So some of you may be just really interested in mathematics and how it works and like in pure mathematics, right? Mathematics for mathematics' sake, in which case it's obvious why you care. But for everyone else who might be more interested in what you can do with math, this is kind of the section for you. Like, okay, why does this even matter? If you're asking yourself this question, like I would ask all the time when I went over stuff like this in school, I want to address that. And maybe these answers will be sufficient for you, and well, maybe not. But here's something. We're going to start. One of the reasons why we care about whether, like, because again, let me be more clear. We're talking about how do we know a solution exists without finding it? And if we do find a solution, how do we know that's the only solution? And that's what we're spending this section talking about. Well, it's very important to know whether a solution is going to exist, mostly because it saves time, right? Like, you don't want to spend all this time looking for a solution if one does not even exist. All right. So there are some, like the existence theorem that we're going to talk about today, can save you some time because you could just look at something and say, I don't even know if a solution is going to exist, which is going to be a problem. But we're going to be able to prove that solutions do exist, and we say, okay, we can try to find them now. But if you don't even know whether something exists, it's much harder to find it. So it can save us time not looking for things that might not be there. Second off is it helps us with physical models. For example, what happens, right? And let's just say, I'll talk about physical models right here. What happens if we have a physical model? We have some kind of situation. Maybe we're mixing tanks. We have a mixing problem. Or maybe we're describing heat transfer or population growth or something. And we find out a solution doesn't exist. That's not possible, right? Like, if we're describing a physical situation, the situation does exist. I see it right there. There are 500 elephants outside and growing, or maybe not. I don't know. That'd be wild, right? But if we create a physical model and there's no solution to that differential equation, that keys us into saying, okay, I think we messed up with our physical model, right? So that's very important, right? If you're describing reality and the solution doesn't exist, well, I mean, I don't know, maybe there's some very cynical conclusions you could make that are non-mathematical about reality, but jokes aside, it tells us that we need to go back and figure out our model and make it better. And then just, one of my favorite things to talk about is that we've already done this. Not with differential equations, but we've certainly done it with equations such as this, x squared plus x plus 1. If I ask you to solve this equation, you know the solution doesn't exist because we can look at the discriminant of the quadratic formula. Remember that if we look at b squared minus 4ac, that tells us a lot of things about solutions to this equation. And if we simplify that, right, that's 1 minus 4. Oh, I guess the discriminant's only the inside. We get the square root of negative 3. We know that we don't have any real solutions to this equation. The real solutions don't exist. We don't have to do the whole quadratic formula. We just look at the discriminant of negative 3, and we can do that. And specifically, we know that if the discriminant is 0, then there's a unique solution to this equation. So we've kind of done this before. Again, maybe that adds more questions about why you care and doesn't answer a question, but something to tie in. All right. So I talked about why it helps for existence, like why existence matters of a solution for physical models. Why might uniqueness matter for physical models? Why might we care whether there's one solution to a physical model or multiple solutions to a physical model? And the answer is, one of the answers is, you might say the answer to this question is not unique either, since there are multiple answers. Anyway, one of the answers to why we care about uniqueness for physical models is if we have multiple answers, if we have multiple functions, well, which one is right. Okay, and we could collect some more data and maybe choose the best one, but it is, something to consider. All right, I think the last thing that I want to talk about is, the cats are playing and the dog is not familiar with it. How do you lay down? All right, and so the last thing I want to talk about in this video is, again, just like if we don't, like for uniqueness, how do we find or know we found all the solutions? And if we know that the solution is unique, then we're done. We don't have to try to find all the solutions. If we don't know the solution is unique, then we have more headaches. It's like, well, I found one solution. Are there more? I don't know. But our uniqueness theorem is going to make that a lot easier for us. We're going to say, yeah, I found a solution. That's the only one. So we are done. And I love being able to say that. So we'll do some practice with all of this. Here's a little bit of motivation for why do we care about whether we know solutions exist? Why do we care about whether we know solutions are unique? And we'll talk about some more applications. Specifically in the fourth video today, we talk about some cool things that you can do with the powers of uniqueness. Anyway, take it easy, and in the next video, we'll introduce our first theorem of this class.